Hello everyone, welcome back to King Solutions. My name is Philip King. Before we begin this video, I would like to ask a favor from you. If you like our videos, then please click on the like button and subscribe to our YouTube channel to show your support. Thank you. In this tutorial, you will find my version of the Ghidra Beginners class. This Ghidra Beginners class closely follows the Ghidra slide tutorial given in the Ghidra documentation, along with a few additional notes and screenshots to, hopefully, help clarify the slides. Why have I made this tutorial? Well, I found following the Ghidra tutorial quite difficult, so decided to produce this derivative. I hope you find it helpful. What is Ghidra? Just in case you don't know already, Ghidra is NSA's software reverse engineering framework. It's been in development for about 20 years but received its public release in March 2019 at the RSA conference. What does Ghidra stand for? It's simply the three-headed monster that brings a hex editor, disassembler, and debugger into one reverse engineering framework. Ghidra was specifically created by the NSA, as a project-based platform to solve hard cybersecurity problems. If you haven't installed Ghidra yet, there's a tutorial on my channel on how to do that. I'll put a link below this video. As stated earlier, this Ghidra Beginners class closely follows the Ghidra slide tutorial given in the Ghidra documentation. If you would like to see the original slides, they can be found in the Ghidra download. Look in the docs, Ghidra class, beginner folder. Okay, let's go through the slides. How to use these slides. Use the arrow keys to navigate to the next or previous slide. To go to a specific page, double-click the page number, and enter the page number you wish to jump to. The with notes HTML file contains detailed notes below the slides. These can be used as a tutorial. To launch the presentation slides, click Pop-up. These slides should display correctly in modern versions of all browsers. Microsoft Edge may display the slides incorrectly at first. To fix this problem, go to Edge Options, and click Zoom once. Installing Ghidra. Download the Ghidra installation file. Unzip the Ghidra installation file. This takes the form, Ghidra, version, release, date.zip. Where version is the version number of the release. Release is the name of the release, and date is the date the release was built. Platforms supported include Microsoft Windows 7 or 10, 64-bit. Linux, 64-bit, CentOS 7 is preferred. Mac OS, OS X, 10.8.3 Plus, Mountain Lion or later. Exercise files. Go through these slides with your choice of program. The exercises were written to work with any program. Note, when they say program, they mean a binary file. Course objectives. By the end of this course you will be able to create, set up, and customize Ghidra projects. Perform code analysis, markup, navigation, searching, selections, and basic data creation to support the reverse engineering process. Use the Byte viewer, decompiler, program tree, symbol table, symbol tree, function graph, and function call tree to support the reverse engineering process. Course topics. Install and introduction. Creating projects. Importing and exporting programs. Customizing tools. Basic code analysis. Selections. Basic code markup. Basic decompiler. Applying data types. Navigation. Searching. Byte viewer. Basic program tree. Symbol table and tree. Function graph. And function call tree. What is Ghidra? Ghidra is an integrated development environment for reverse engineering tasks. It is written in Java, so is mostly platform independent. Ghidra consists of 5 major parts: programs, plugins, tools, project manager, and server. Ghidra is a highly extensible application for performing software reverse engineering. It is built upon a completely generic application framework. Each application-specific capability is provided by small software bundles called plugins, and each one provides one or more features. As stated above, there are 5 major parts of Ghidra, and each of these parts will be discussed in more detail later on in the course. Programs. All data is stored using Ghidra's custom database. All data added by the user also gets added to the Ghidra program database. This includes symbols, bytes, references, instructions, data, and comments, etc. Plugins. Ghidra is a library of plugins. Each plugin provides specific functionality. All plugins communicate with each other within the tool that they are docked in. Plugins can be added or removed without restarting Ghidra so that users can customize the tool however they like. Users can also write their own plugins. Although Ghidra provides a core set of plugins, you may create your own to add more functionality. You can also create tools by combining different plugins to achieve a specific requirement. Tools. Tools are collections of plugins and their configurations. Ghidra has several pre-configured tools which can be customized to suit individual requirements. All tools can be customized. New tools can be created by adding plugins to an empty tool, and all tool configurations are saved for the next use. Ghidra tools that share data and interact dynamically are said to be connected via tool events. Tools generate events when you open or close a program, move the cursor to a different location, or make a selection in the program. The main reason to connect tools is to have one tool track program location or selections in another tool. Project Manager. The Project Manager manages projects, tools, and data for a particular group of programs. Programs must be imported into a project before work can be done. Project configurations are saved for the next use. Ghidra Server. Ghidra projects can share project data by connecting to a Ghidra server. The Ghidra server is used when multiple users want to work together on the same program or set of programs. It is a simple service running on any computer that a group of users has access to. The server provides network storage for the shared project, and also controls user access. It allows files to be versioned, and supports checkout, check-in, and version history. Why use Ghidra? Some of the many reasons to use Ghidra include: all tools can dynamically share data. Ghidra supports teams. It has a highly configurable environment and is very extensible. It runs on multiple platforms. The application also has a great undo facility. Starting Ghidra. Run the following from the Ghidra installation directory. For Windows users, Ghidra run bat. For Linux or Mac OS users, Ghidra run sh. Note: the first time you run Ghidra you may be asked for the path to your Java installation. To run Ghidra, double-click the Ghidra script file for your operating system. This is located in the Ghidra install directory. The first time Ghidra runs, it may take a few minutes while it searches for plugins and other dynamic extensions. After the first time, it should start much faster. Furthermore, the first time you launch Ghidra, the Ghidra user agreement is displayed. Also, a help window may appear displaying the What's New page in Ghidra. If this window appears, you can dismiss it for now. You can always get it back using the help subsystem, which will be explained later. An empty Ghidra project window should now be displayed. This window will allow you to manage your tools, data, and projects. Program Manager Layout. The Program Manager is a place to create, open or archive projects. These projects can be non-shared projects for individual users or shared projects for a team of users. Import new programs into a project. Note that each project can contain multiple programs. It is also the place to open programs in tools and create subfolders. You can also use the Program Manager to view and open the contents of other projects. You can manage your tools in Program Manager. To open programs in existing tools, simply drag and drop the program onto the tool in Tool Chest. You can store your project data archives, and store version tracking sessions. Use Program Manager to view information about programs using tree or table view. And additionally, you can use the Program Manager to create and switch Ghidra workspaces. Program Manager. Creating a new project. The first thing you must do in Ghidra is create a project. Projects are used to store all the programs and related information together in one place. This helps Ghidra locate the files, making them easily accessible to the user. To create a new project, select File, New Project from the Ghidra project window. Then select the project type. Select Non-shared if working alone, or shared if working in a group. Next, select a project directory and name. The directory should be on a local drive and not over a network for best performance. Finally, enter a name for your project, and select Finish. Projects are populated with data using the import process, which will be explained in the next step. Exercise 1. Create a new project. This is a non-shared project using the default project directory. Name it, My Project. After completing this exercise, you will have created a new Ghidra project. At this point, you should see tools in the tool chest and should see a folder named My Project. Project Manager. Import Program. To import a file, select File, Import File and browse to the program you want to import. Alternatively, drag and drop from the file system onto a Project Manager folder. If you want to see the list of formats Ghidra supports, click on Supported Formats. Ghidra can import PE, ELF, raw binary, Intel hex, GZF, which is the Ghidra zip file format, and others. Either use the default, or choose an alternate file format and language. If a recognized type, Ghidra will fill in the correct file format. Otherwise it will show raw binary, and you must choose the correct language and compiler. You may always choose raw binary if you do not want any imported information. In such cases, you must choose the correct language and compiler. Exercise 2. Import Program. Import a program of your choice. Use auto-detected format and language. Turn on the Load External Libraries option and see if any DLLs are loaded with your program. Open program in tool. There are different ways to open programs in a tool, including clicking and dragging a program onto a tool, clicking on a tool to bring up an empty tool, then choosing File Open from the Tools menu. Dragging a program from the file system onto an empty tool will start the import wizard. You can also open multiple programs simultaneously, in which case the programs will be tabbed in the tool. How to start auto-analysis. When a program first opens in the tool, it automatically kicks off auto-analysis, which asks the user if they want to analyze the program. If you choose not to start auto-analysis right away, you can start it later by selecting Analysis Auto-Analyze from the menu. There are numerous analysis options that can be chosen. The default options change depending on what type of binary has been imported. Certain analyzers are also kicked off whenever specific actions are performed, such as code disassembly, function creation, and data creation. During auto-analysis, Ghidra starts at entry points and disassembles by following flows. It creates functions and cross-references at called locations. Depending on the option selected, auto-analysis may do other things as well. This includes using operand references to create code or data where an operand points to, making switch statements using decompiler information, making function signatures based on decompiler information, demangling mangled names, recognizing and naming library functions, performing specific functions depending on the binary type, looking for images. If you would like to cancel auto-analysis at any time, you can click on the little red square at the bottom of the listing. You can also view the log in the bottom right of the Program Manager to see which analyzers were run and how long they took to complete their task. Auto-analysis. It's useful to take a layered approach with analysis by running with basic options first, and then running one-shots later. In the initial analysis, focus on options that will get function starts and data first. Turn off anything speculative or extra, such as stack analysis, especially if you have a large binary. You can turn these options back on after an initial analysis, and rerun analysis on selected functions or the whole program. In general, you should leave on reference, data, and function analyzers, in order to determine what is code, and what is data. In the follow-on analysis you can rerun analysis with different options. Alternatively, you can turn on one-shot analyzers, which are analyzers that run one type of analysis at a time. One-shot analyzers can be run from the Analysis-One-Shot menu. Some common one-shot analyzers are Decompiler Parameter ID, Decompiler Switch Analysis, and Stack. You will also need to learn how to recognize and fix problems. For example, red X's indicate bad flow. The error bookmarks may indicate which analyzer caused the problem. You can then rerun with better options. Analysis may not completely determine all code and data in a program, especially if certain analyzers are turned off. Ghidra also has many useful scripts to help you recognize and fix problems. For example, the fixUpNoReturn function.javascript fixes functions that do not return, and the resulting bad flow from the call to the function. To open the Script Manager window, use the Windows Script Manager menu item. Exercise 3. Auto-analysis. Open your program in the code browser. Auto-analyze your program using the defaults. Code browser layout. The code browser is the default tool, created by configuring Ghidra plugins in a way that makes it useful for disassembling, navigating, and documenting assembly code. It has been configured to provide all the basic functionality needed to reverse engineer a program. By default, the code browser is configured with the program tree, a symbol tree, a data type manager, the listing, a console, and a decompiler. Extra windows are located in the Windows menu. The code browser tool also consists of pre-configured plugins. Users can add additional actions and more plugins into a particular tool, such as the code browser, by using the file configure action. Useful info. F1 Help. There is extensive help that explains each action in Ghidra. Help can be obtained by hovering on an action and pressing the F1 key. F1 also works on any open window. The entire searchable help document can be obtained in Ghidra by clicking on Help Contents. F4 Set key bindings. Within a tool, you can give each lowest level action a key binding, or change the default key binding. In order to do this, hover on an action and hit the F4 key. An alternative method is to go to Edit Tool Options, to find a list of all key bindings, and then edit from there. Undo or redo. Within the code browser and other similarly configured tools, each action, no matter how big or small, can be undone or redone by clicking on the curvy arrows at the top of a tool. Hover on the arrows first to see what action you are undoing or redoing. Note, the undo history is cleared after a save. Main versus context-sensitive menus. Main menus and sub-menus in general are used for global actions. The right-click menu is context-sensitive, which means that different actions are available on the right-click menu depending on what item your mouse is on. Commonly used features placed on icon bar. Hover on icons to see their function. Closing a tool versus exiting Ghidra. To close a tool, either click the X at the top right of the tool or use the File Close tool action. To exit Ghidra, choose File Exit Ghidra, from any tool or the project manager. Alternatively, click the X at the top right of the project manager. Note, you do not need to close your tools before exiting Ghidra. In fact, if you want to pick up where you left off, Do not close your tools. Simply exit Ghidra and your state will be saved. When you reopen Ghidra, everything will be as you left them. Cursor versus selection-driven actions. If there is no selection, many actions act only on the current cursor location. When there is a selection, these actions will act on an entire selection. Selections and highlights. Selections are temporary, in other words, they go away when a user clicks in a listing. They show up in green in the tool. They can be created manually by click and drag, and by using the select menu. They can also be created from tables by selecting rows and doing right-click make selection. Selections and searches use the current selection by default. Highlights, on the other hand, are semi-permanent, in other words, they do not go away until the user clears them using the menu item select program, highlight clear. They show up in yellow in the tool. Listing. A listing consists of typical assembly code fields: address, bytes, mnemonics, operands, comments, and labels, etc. Listing fields can be customized using the field editor. Field editor. The field editor is used to customize the listing fields. Add, remove, enable, disable, move, and resize. To use the field editor, use the Edit the Listing Fields icon, in the top right of the listing, to toggle open or to close the field editor. Field groupings are different depending on what area of the program your cursor is on. Examples of different fields include code data, open array or structure, and function signature. When the cursor is on the current field, the field will be highlighted in the field editor. Use the mouse to move or resize the fields. Notice their counterparts in the listing also move and resize at the same time. Use the right-click menu to choose from a variety of options including enable, disable, add, or remove fields. Docking windows. Most windows can be docked, undocked, or resized, and relocated to other parts of the tool. To dock a window, click on the title bar of the window so that it turns blue. Now drag the window to the top, bottom, right, or left edge of another window. When you see a black arrow, then drop the window and it will now be located above, below, to the right or to the left of the other window. To create tabbed windows, drag the window so that it is overlapping another window. When you see overlapping boxes, drop the window and it will be tabbed on top of the other window. You will see a circle with a slash if you cannot drop the window. Clicking on the tabs below the window will determine which window is visible. To undock a window, simply drag and drop the window outside of the tool. To resize a window, click and drag the window edges or corners. Note: you can drop the window outside the tool and it will still be functionally connected to the tool. If you want to dock a window that is not already docked, you need to click and drag using the inner bar that contains the title of the window. It will turn blue when you click on it. Edit tool options. All tools have different options depending upon which plugins have been added to them. To edit options in any tool, use the Edit Tool Options menu item in that tool. This will open the Edit Options dialog. There are hundreds of options within the Edit Options dialog. Users can use the filter option or tree to find the option needed within the dialog sub-windows. For more information about a particular subset of options, hit F1 while in that particular Edit Options sub-window. Ghidra does not need to be restarted for edit options to take effect. Modified tool states can be saved to the current tool or to a new tool with a new name and icon. To save the tool state, use File Save Tool, or File Save Tool as menu items. A tool can be exported, then imported for others to use. In order to export a tool, go to File Export Tool. To import a tool, go to Tools Import Tool to import any tool from the project manager. Exercise 4. Customize the code browser. Change your instruction fields. Enable the P-code field. Add the stack depth field to the right of the operands field. Look at the resulting changes to your listing fields. If you like the changes, keep them, or if not, disable or remove the fields you do not want. Open the function graph window and dock it so that it is tabbed on top of the decompiler window. Change the code browser's edit tool options key binding to Shift-O. Change the code browser's tool options so that docking windows are on top. To easily find the option, try using the filter. Hover on File Save Tool As, and use F1 to bring up help describing how to save a tool. Save your new tool with a new name and new icon. Basic Code Browser Navigation. Basic Code Browser Navigation consists of scrolling, paging up and down, double-clicking on anything with a reference, and using GoTo from the navigation menu or G hotkey. More Code Browser Navigation. Using the navigation history arrows and pull-down list, users can navigate addresses. You can select addresses visited before, or select from the pull-down list. Selection and highlight arrows. If there is a green selection or yellow highlight, these arrows will allow navigation to different ranges of the selection or highlight. Navigation buttons. The main menu bar contains the navigation buttons. The buttons have the following attribute. The blue up or down arrow toggles direction. The I button navigates to the next range of instructions. The D button navigates to the next range of data. The U button navigates to the next range of undefined bytes. The L button navigates to the next label. The F button navigates to the next function. The Not F button navigates to the next range of instructions not in a function. The Not V button navigates to the next range of bytes not equal to the current byte value. The B button navigates to the next bookmark. Note, you can also use the pull-down arrow to change to a specific bookmark type. Navigation markers in right margin. The markers show up in the right margin for the current overall view. The view is determined in the program tree window by the small red flag. Click on a marker to navigate to that location in the program. Right-click on the margin to see the various types of navigation markers. You can select and deselect what is shown in the margin from the right mouse menu. The following are a few examples of the different types of navigation markers. Orange, Analysis Bookmarks. Black, Changes since last save. Purple, User Bookmarks. Green, Current selection. Yellow, Current highlight. And red as error bookmarks. External program navigation. You can navigate to other programs by clicking on an external reference. The external reference must exist. If you have the external program imported into your project and the external references have been created, you can click on the external reference and navigate to the external program. If the program is not open, it will be opened and tabbed in the listing next to the current program. Using the Load External Libraries Importer option, will do this automatically for some formats. To create external references automatically, choose Load External Libraries in the File Import File Options dialog. You can also use the Reference Manager to create a reference manually. To create external references manually, right-click on the place you want to create the reference in the listing. Next, select References Add or Edit, then click on the green plus button. Finally, click the External button. All references from one external library will be created if you do this for one of them. Basics of a table. All tables have the following basic features. Navigation. You can navigate by address or label column. Just click on the value in the column to start navigation. Sorting. You can sort by any column, ascending or descending. To sort, click on the top of the column and you will see a stair step indicating ascending or descending. Then click to reverse. You can subsort by doing Control-click on the other secondary columns. Filtering and filter options. You can type the filter value in the bottom text box and press Enter. The filter option has a default setting that will filter out any row that does not contain the text in the filter unless you change the default option. This is done using the button to the right of the filter. Other filter options include, starts with, matches exactly, regular expressions, case sensitive, inverting the filter, and multi-term filtering. Add and remove columns. You can right-click on any column and choose to remove it or add a new column next to it. Move columns. You can move columns by clicking, dragging, and letting go of the click where you want the column to end up. Column settings. Some columns have special settings you can change using the right-click menu. Selections. You can make selections in the listing by selecting rows from the table and choosing right-click Make Selection. Copy. You can select rows and copy text to paste in any editor such as Notepad, Ghidra Comment, etc. Export to CSV text file. You can also export a table selection to a comma-separated value text file. Exercise 5, Navigation and Tables. Use the Go To feature to bring up a table of labels starting with Fun. Dock your table over the Decompiler. How many entries are in your table? Add the function size field to the table. Sort the table by function size so that the smallest function is at the top. Navigate to the smallest function in your table. Use the filter to show a subset of items in your table. If your program is a Windows GUI program, use the Go To feature to bring up a table of all labels that start with RSRC to see the resources used in your program. Code Browser. Features for understanding code. Instruction Manual. Right-click on any instruction and choose Processor Manual from the menu. If the manual is in your installation, your default web browser will open the manual to the first page containing that instruction. If your web browser does not allow page numbers, the first page of the manual will open. If the manual is not in your installation, a link to the manual will be shown, along with instructions for installation. Info fields at bottom of browser. This window shows what the original assembly looked like before Ghidra marked it up. The current address window shows the address of the cursor and the function name. Hover. Use hover by placing the mouse over items with references or data types. This action will display a temporary window with a reference to the item or data definition. The hover window will be visible as long as the cursor is within the window. Cursor text highlight. Clicking on any text in a listing field with the middle mouse button will highlight in yellow all matching text in the listing. You can change the colors or the default behavior of this feature by going to Edit Tool Options. Snapshots. You can make as many snapshots of the listing and other windows as you would like. Snapshots have a yellow ring around them and you can dock them anywhere just like any docking window. They have the same functionality as the original window, but don't track with the listing. Snapshots are valuable because they enable you to see more than one view of the code at the same time. Decompiler and references are described more fully in future slides. References. Xref field. This listing field contains a list of all addresses that reference the current address or item. Each item in the Xref field has a type indicator next to it. The Xref header. This is located above the Xref field and shows how many references there are to the current address and item. You can double-click the Xref header to bring up a table of all of them. Show references to. Another way to bring up a table of references is to click on the item and choose References Show References to. Edit and create references. To edit or create references, right-click on an operand or instruction and choose References Add or Edit. Use the green plus icon to add a reference. Choose the type of reference you wish to create, memory, external, stack, or register. Fill in the appropriate text boxes with address, offset, and external location. The text boxes will vary depending upon the type of reference you pick. You can edit and create references anywhere. Code Browser. Basic Markup. Labels and comments are ways for you to annotate what is happening in the code or data. The following are the basic steps for editing or creating labels and creating comments. To create a label, click on an address and choose the L key, or right-click the address, and choose Add Label. To edit an existing label, click on the label and choose the L key, or right-click the label, and choose Edit Label. To create a comment, click on any field in a code unit, and choose the semicolon key, or right-click and choose Comment. Then choose the type of comment you wish to create. There are 5 types of comments. An EOL comment shows up at the end of the current line. A plate comment shows up above the current line and is surrounded by a box. A post comment shows up below the current line. Pre-comments show up above the current line. A repeatable comment shows up anywhere the current address is referenced. Exercise 6. Listing Understand and Markup. In your current program, navigate to a small function with a default function name. Use only the listing features, such as cursor text highlight, instruction manual, references, etc., to figure out what the function is doing. Give the function and its parameters descriptive labels, and use comments to annotate what is happening in the function. Decompiler Overview. Converts assembly to P code to C code. Assembly and C code not one-to-one match. Decompiler output may change due to program changes. Changes to data or functions called by the current function. Changes to data mutability, read-only and constant or volatile. Selections and navigation made in listing and decompiler track one another. Basic decompiler features. Editing using the decompiler. The decompiler usually gets things right, but if necessary, you can manually edit parameter, local variable, return types, and names, function signature options, structure members, and names, etc. Edits to items in the listing or decompiler will also be reflected in the other windows. You can edit these items individually by clicking on them in the decompiler or listing, and choosing the appropriate action from the right mouse menu. Alternatively, you can edit several at once by editing the function signature. To do this, right-click on the function signature and choose Edit Function from the listing. Alternatively, you can select Edit Function Signature from the decompiler. In general, users should change function signatures called by multiple places, instead of changing local variables in each individual function that is called. The local variable types will automatically update when related function signatures are changed. The more information you can fill in about data types, especially structure information, the better the decompiler output will be. It is most important to get the correct number of parameters even if you do not know the types yet. If you have associated header files, which you can pull in information from, it will allow the decompiler to propagate that information into the calling functions. Basic decompiler features. Automatically create structures. If you suspect a variable is an undefined structure, you can have the decompiler try to figure out the structure definition for you. Do this by right-clicking on the variable and choosing Auto Create Structure. Decompiler Parameter ID. This is an auto-analysis option that runs through the program. It locks what the decompiler figures out throughout the program. Any future changes to other functions or data that would have affected that function will not be considered. Use this option only if you have rich data type information first, such as Windows known library and DLL calls with parameter and return types applied. This should be during the import process or before running analysis with this option. Committing parameters, return, and locals. This option does the same thing as decompiler parameter ID, but is actioned individually and manually by the user. It can be done separately to parameters, returns, or local variables. Caution: only use this feature if you want to lock the decompiler output instead of adjusting to program changes. Follow variable use. Middle mouse click gives simple text match highlighting similar to listing cursor text highlight on non-registers. Highlight def use highlights where the current variable is used and defined. Similar to listing cursor text highlight for registers. Forward slice highlights each variable whose value may be affected by the value in the current variable. Backward slice highlights all variables in the function that contain a value involved in the creation of the current variable. Export current function. This feature allows the user to export the current function to a text file. Recommended decompiler techniques. Change function signatures to cause global improvements. If you see a function that isn't getting the correct number of parameters or types, you can fix it by applying specific data types to the parameters or adding or removing the parameters. However, adding or removing the parameters forces the decompiler to use your information everywhere that the function is called. Be careful, this can be good if you get it right, or bad if you get it wrong. Make function signature changes to handle specialized types of functions. Users should change function signatures called by multiple places instead of locals in each individual function that is called. However, in some special cases, such as functions with variable numbers of arguments, you can override a signature from the call. Use the override signature action from the right mouse menu in this case only. Apply read-only memory and volatile memory settings correctly. Examples of read-only memory include indirect pointers to data and global values in memory used as constants. If the decompiler thinks the pointers are not constant, then it won't follow them to the data they are referencing. Exercise 7. Decompiler understand and markup. Navigate to a function that calls the function you annotated in the previous exercise. Using your understanding of that function, use the decompiler and its features to start understanding the calling function. Start by using what you know about the previous function's parameters and what it returns, to start labeling variables in the calling function with descriptive names. Once you see the descriptive names used elsewhere in the function, it may help you understand more about the function. Continue labeling variables and parameters as you figure out their purposes until you have a good understanding of at least part of the function. Code browser markup. More about labels. Labeling. Multiple labels. Labels can have more than one label at an address. Primary label. Primary labels show up in references by default. You can change which label is primary using Edit Label action. To add another label, right-click on the address and choose Add Label. Locals and globals. Global variables exist in the whole program and can only have one unique name. Local variables exist in a namespace and can have more than one of the same name. Labels inside a function are, by default, in that function's namespace. The namespace can be changed using the right-click Edit Label action. Function signature. The function name in the function signature is the same as the primary label at that address. You can add secondary labels at the function entry point address, but only the primary label is reflected in the function signature name. Show history. Use right-click Show Label History to see how the label has changed and who changed it. Search Label History. You can use Search Label History to find an old label name that does not exist in your program anymore. Code browser markup. More about comments. Comment annotations. Embed display markup in Ghidra comments. To add comment annotations using the comment editor, use the pull-down menu, choose an annotation type, and then click the Add Annotation button. Comment annotations appear as hyperlinks to the items. Double-click to navigate to the item. Types of annotations. Address. Enter the interesting address. The comment will display the given address as a hyperlink. Double-click the link to navigate to the address. Execute. Enter the path to an executable. Double-click the resulting link to launch the specified executable in your operating system with any given optional parameters. Program. Enter an existing Ghidra program name, which is case-sensitive, to displays a hyperlink to the given Ghidra program name. Double-click the link to open the program in a new listing tab. Optionally, use the @ name after the program name to go to a specific symbol in the program. Symbol. Fill in the address of the interesting symbol. The comment will display the given symbol as a hyperlink. Double-click to navigate to the symbol. Changes to the symbol in the listing will automatically change the comment to display the new symbol. URL displays the given URL as a hyperlink. Double-click to open the link. References which refer to a program within a Ghidra server repository will be opened within the listing display. All other URL protocols will be launched via an external web browser. Applying data types. You can apply a data type to a single address or a selected range of addresses. If you apply a data type to a selection, that data type will be applied contiguously until it reaches the end of the selection. You can also apply a data type to a parameter or a local variable. Applying data types. Data Type Manager. The Data Type Manager normally resides in the lower left corner of the code browser. If it is not there, you can open it using Window Data Type Manager. There are different folders for each of the following data types. Built-in types contain data types created by the Ghidra development team. Program data types contain data types that have been applied to the current program. Pre-built data types contains data types parsed from data definition files. There may be more than one folder of this type. Your own data archives contains data types created by the user. Users can create their own data archives so they can use their data in multiple programs or projects. These archives can be stored on the file system, file archive, and shared by multiple projects. Alternatively, they can be stored in the current project, project archive, and be shared by all programs in the current project. To find the data types you are looking for, you can use the filter or simply open the folder using the pull-down menu to find by size or name. To apply data, click on the data type and drag it to a single address, a selection, or parameter. Applying data types. Right mouse menu. There are two ways to apply a data type from the right-click menu. First, click on an address or select a range of address where you want to apply the data type. Then choose either. Right-click menu, data, choose data type, then browse or start typing the name of the data type you want to apply. Or, right-click menu, favorite list, then choose a data type from the list of your favorite data types. This can be customized in the Data Type Manager by toggling the right-click favorite action. Applying data types. Cycle groups. When applying data in cycle groups, click on an address or select a range where you want to apply the data type. Use the right-click Data Cycle Groups menu, or the following shortcut keys to cycle through the following data types. B for byte, word, D word, and Q word. Quotation mark for character, ASCII string, and Unicode string. F for float, and double. Functions. Functions are well-formed subroutines. Create them by first disassembling D key, then hitting F key at top of function. You can edit each individual piece of a function signature in the listing or decompiler. You can also use the edit function action to bring up a dialog to edit multiple items at once. Code browser markup. Clearing. In order to use markup clearing, you need to select the items you want to clear, and choose one of the following markup clearing options from the right-click menu. Clear code bytes. This option clears the defined code or data and leaves labels, comments, etc. alone. Clear with options. This allows you to choose which items you want to clear. Items such as symbols, comments, code, functions, references, and bookmarks, etc. Clear flow and repair. This allows you to clear and repair code which was produced in error. Click on the first bad instruction, and then invoke the action. Code browser markup. Constants. Convert. The convert action only appears on the right-click mouse menu if the cursor is on a constant operand. It only works on the current scalar. It can display a constant in different formats such as binary, decimal, and characters, etc. Equates. The set equate action only appears on the right-click mouse menu if the cursor is on a constant operand. It only works on the current scalar, if there is a selection on all matching scalars in the selection. Equates can replace a constant with a descriptive name. Some are predefined from parsed header files, or a user can make their own. Enums. You can group equates into an enumber. To group equates or enumbers into a single enumber in the data type manager, try using the filter to group them where possible. Then select them using click and drag, followed by right-click Create enumber from selection. It can apply to the code browser individually or to a selection. It can also apply to the decompiler by changing a variable data type. Note, applying to the listing will apply names to most matching scalars in the decompiler. However, the best way is to use the decompiler and get the data types correct. Note: the apply enumber action allows users to apply the enumber names to multiple matching values in instructions. It only appears on the right-click mouse menu if the cursor is on a constant operand, or there are constant operands in the current selection. Applying equates and enumber to the listing will rename most in the decompiler, however the preferred method is as follows. To apply enumber names to the decompiler view, find a variable being assigned or compared to the constants, then do right-click Retype Variable, or right-click Retype Global. Make sure that the enumber size, 1, 2, 4, or 8 bytes, matches the size of the variable in the decompiler or it will not display the names. Exercise 8. Constants. Find a scalar operand and use the convert action to convert it to a different format. Find a scalar operand and use the setEquate action to rename it to either a name of your choosing or from the given list. Code browser markup. Bookmarks. To create a bookmark, right-click on an address and choose Bookmark from the right-click menu. Then fill in an optional category and description. If there is a current selection, bookmarks will be made at the top of each selected range. A purple checkmark will be placed at each bookmark location. Bookmarks show up in the left margin for the currently displayed code. They will be in the right margin when in listing view. If you would like to see a list of bookmarks, open the Bookmark Manager in Window Bookmarks. The bookmark table allows filtering by text, and/or bookmark type. Types of bookmarks. User notes, displayed as a purple check symbol, this shows bookmarks the user has added. Analysis, displayed as a blue bold symbol, shows bookmarks that auto-analysis added to describe which analyzer created the code and data at that location. Information, displayed as a white circle with I in the middle. This bookmark is added by importer, to describe which items the importer identified in the import process. Error, displayed as red X symbol. This shows bookmarks used to indicate an unknown opcode. It can be caused by bad auto-analysis disassembly, or bad user disassembly. Warning, displayed as a yellow triangle. It shows bookmarks used to indicate a possible problem. You can use Bookmark Manager to view all bookmarks. Exercise 9. Bookmarks. Create bookmarks at the tops of the functions you chose to annotate in exercises 5 and 6. Bring up the Bookmark Manager, and use it to display only user-created bookmarks. Try this 2 different ways. Use navigation markers and the left margin markers to inspect some of the analysis and info bookmarks. Toggle off the analysis markers in the right margin. Export formats. Ghidra allows users to export a selection or an entire program to the following formats. Ghidra zip file, GZF. This uses a custom format to compress all information contained in a Ghidra program, so that users can share program information. XML. This is used to export information about the current program to other tools. Note that there is a potential loss of information due to inconsistencies between tools. An exemplar IDA Pro set of plugins and loaders are included in the Ghidra folder, extensions IDA Pro. Also included is an IDA Pro export plugin. This creates XML that Ghidra can import. HTML exports selection, or entire program as navigable HTML. Binary exports selection, or entire program as binary. Intel hex exports selection, or entire program as Intel hex format. C exports selection, or entire program, as C code, including corresponding .h file. ASCII exports selection, or entire program as printable ASCII file. Program tree basics. The program tree is normally open in the top left of the default code browser. If it is not visible, go to Window Program Trees, to open. The program tree can be used to see the basic structure of the program. It can also be used to organize a program. It can be used to select whole memory blocks. You can also use the program tree to change the current view in the listing window. You can use the tree to determine where your cursor is located within the program. You can also have multiple trees with different organizations. A program tree can be created by the import process's read of the program header, or by the user, when they import or split the program into different code or memory blocks. In the program tree, you can create folders and fragments. Select code and data, then drag it onto a folder or fragment. Although items can only exist in one fragment, the same fragment can exist in multiple folders. Structure your visualization of the program. Although the program still exists in the same address order, your visualization of it is rearranged in the tree. You can also make multiple program trees, each with different organizations of the program. You can create a new tree by clicking on the new tree icon, in the top right of the program tree. Program tree view. A red flag indicates the view currently contained in the code browser listing. Double-clicking on a fragment or folder changes the view to that fragment or folder. Track the listing. Click on the icon with a green arrow in the top right of the program tree and the segment containing the current location in your listing will be selected. Program tree modularization. You can modularize code only programmatically by subroutine, complexity depth, and dominance. It's best to create a new program tree every time you modularize, as the modularization actions do not work effectively on already modularized trees. In the program tree, right-click on a code segment and choose Modularize by dash. Selecting subroutine, breaks code into segments by a chosen subroutine model. Selecting complexity depth, groups functions into folder levels. Level 0 contains the entry functions. Level 1 contains functions called by entry functions, and so on. Other levels contains functions that do not call any other functions within the current program, but may call external functions. Selecting dominance, will group functions in folders, according to which functions dominate other functions. For example, function A dominates function B, if every path from the entry to function B, must go through function A. Exercise 10. Program tree. Make the program tree follow the listing. Make a new program tree, then rename it My Tree. Make a folder called My Interesting Functions. Make a folder called My Interesting Data. Select any functions or data you think are interesting, and drag and drop them into the appropriate folders. Make one or more new program trees and modularize each one with a different modularization technique. Byte Viewer Basics. To open the Byte Viewer window, go to Window-Bytes Program. Byte Viewer allows you to view and edit program bytes in various formats. Byte Viewer navigation tracks the listing and vice versa. To edit. You can edit the content of the Byte Viewer by selecting the pencil icon. If editing code bytes, clear them in the listing before editing, then redisassemble. There is no need to clear if editing data bytes. You can edit in whichever Byte Viewer field makes most sense. For example, if you want to change ASCII, just type in the ASCII field. To add fields within the Byte Viewer, select the wrench icon. Choose from hex, binary, ASCII, octal, hex integer, address, integer, or disassembled. Searching. Search program text. Search allows users to search for any markup text put there by Ghidra or the user. This includes comments, labels, fields, etc. You can search on whole program or a selection. You can search next or previous or search all instances to bring up a table. To open the search program text dialog, go to Search, Program Text. Searching. Search memory. Ghidra allows users to search for bytes contained in all, or a selected portion, of program memory. You can search next or previous or search all instances to bring up a table. To open the search memory dialog, go to Search Memory. You can enter a search value as hex, string, decimal, binary or regular expression. Choosing these options brings up other sub-options if applicable. Using regular expressions in search memory allows a more flexible byte pattern search. Searching. Search for strings. Ghidra allows users to search for strings in all, or a selected portion of memory. To open the Search for Strings dialog, go to Search, Search for Strings. By default, searches are performed for null-terminated ASCII and Unicode. Search for Pascal is also available. Searching. Search for direct references. Ghidra allows users to find places in a program where bytes represent the current cursor address, or selected addresses. To open the Search for Direct References dialog, use Search for Direct References. A direct reference in Ghidra is a reference that uses bytes to reference an address. Searching. Search for address tables. Search for address tables allows users to find runs of direct references to addresses. To open the Search for Address Tables dialog, go to Search for Address Tables. You can create address tables directly from the table using the Make Table button. This will create a label and address data type for each item in the table. If it is determined that the table values all point to code, you can kick off disassembly at each address referenced by the table, with the Disassemble button. Searching. Search for instructions. The Search for Instructions allows users to find matching instruction patterns. You can specify whether to include or exclude operands. To open the Search for Instructions dialog, go to Search for Matching Instructions and select an option. There are two actions that allow you to search for instruction patterns. Both work on either the current instruction or a selection. Where option indicates whether to include or exclude operands. Searching. Search for scalars. This allows users to find all operands that are scalars, and to find data used as scalars. The user can specify a range of scalars or a specific scalar. To use Search for Scalars, go to Search for Scalars, then fill in range or specific scalar in hex or decimal. Exercise 11. Search. Search your program for interesting strings and scalars. Symbol Table Basics. The symbol table displays information about every symbol in the program. To open the symbol table window, go to Window-Symbol Table. You can see the type of symbol, such as function, data, and instruction labels, plus parameter and local variable names. Also displayed is the reference and offcut reference counts. The namespace displays the namespace that the symbol belongs to, or global if it is defined in the whole program. The symbol source, such as user-defined, imported etc., is also available. The filter dialog allows filtering on numerous items such as symbol source, symbol type, and so on. Symbol table. Reference window. The symbol table reference window shows information about the currently selected symbol in the symbol table. To open the symbol table reference window, go to Window-Symbol References. The different modes in symbol table reference window can be selected using the icons in the upper right corner. The modes include S mode, the default mode. This shows all references to the selected symbol, a preview of the reference and the type of reference. I mode. This shows a preview of all navigation instructions contained in the selected function. D mode. This shows a preview of all data references contained in the selected function. Note, the IND modes only work if the selected symbol is a function. Symbol tree basics. A symbol tree organizes symbols according to type, in a tree view. It nests symbols belonging to other items under that item's folder. You can also have it track the listing and create classes and namespaces. To open the symbol tree window, go to Window-Symbol Tree. Note, the symbol tree window is generally open by default, and located in the main Windows left-hand pane. Windows menu. Previews. The data type and disassembler preview windows are used to help determine undefined areas. To open the data type preview window, go to Window, Data Type Preview. The window changes what is displayed based on where you click in the listing. The bytes at the address are displayed in the various formats in the table. You can add or remove data types using the plus or the X icon. To open the disassembled view window, go to Window, Disassembled View. The window changes what is displayed based on where you click in the listing. The bytes at the clicked address are displayed as they would look if they were disassembled code. Windows menu. Defined tables. Defined tables shows all defined items of type data, function, string, and equates. To open a defined data, functions, strings, or equates window, go to Window, Defined Data, Functions, Strings or Equates table, as required. Windows menu. Script Manager. Unlike plugins that stay around once they are configured, scripts are meant to be one-shot actions. To open the Script Manager, go to Windows Script Manager. To run a script, select it in the Script Manager and either double-click the table entry or click the green circle icon. Any script messages will be displayed in the Smart Console. Being smart, if the console recognizes a label or address, you can click on it in the console to navigate in the listing. Function graph. The function graph represents functions as a directed cyclic graph. To open the function graph window, go to Window, Function Graph. Edges, branching or jumps, within the graph represent flow control. Conditional positive, success, is green. Conditional negative, failure, pass-through, is red. Unconditional and switch are both blue. Each node or block represents a unit of code. If the satellite view inset window, at the bottom right of the main window, gets in your way, you can right-click on the function graph canvas window, and deselect its option. If you hover on an edge, it will present a pop-up window showing you the branch or jump statement, and the code at the target destination. This can obscure a large portion of your window. If you would like to turn it off, you may do so using the right-click menu. If you don't like the colors used, you can change them using the Edit Tool Options screen. Function graph. Basic controls. These are the function graph basic controls. Click and drag on white space will enable you to move the canvas. Clicking on a block will navigate and focuses within the listing. Double-clicking on an edge navigates to the jump target destination. Double-click again and it will navigate to the jump source, the branch statement. Double-clicking on block centers will zoom to 1-1. The mouse wheel also enables you to zoom in and out. Note, the focused block is the block containing the current cursor location in the listing. The block or node in the graph, surrounded by a yellow highlighted oval, is the focused block. If you click on a block, the cursor is placed at the top of the block. But if you navigate using the listing or decompiler or other window, your current location can move to a place within the block. If you navigate outside the current block, the focus will follow. Function graph. Basic controls continued. If you zoom out too far, the block contents will be blank and no block interaction is possible. In the satellite view, the entry point will show as green and the return blocks as red. Your monitor might report strange values for its actual resolution, which will confuse Java. Function graph. Node buttons. The node buttons, top right of each block, have the following actions. Clicking the paintbrush icon, sets the background color for the block. Clicking the window icon, switches the view from window to full screen. Clicking the chain icon, will cause a jump to one of this function's xrefs or callers. Function graph. Window buttons. The window buttons, top right of window, have the following actions. Home, move to entry point block. Layout, select layout. Field editor, change block field layout, this is independent of main listing field layout. Hover/focus, discussed next slide. Camera, make a snapshot window. Function graph. Hover and focus. There are two pull-down menus in the graph window icon bar. Each mode contains almost the same set of options that are explained in the next several slides. The difference is in how they are enabled and displayed in the graph. Hover mode. This is enabled when placing the cursor over a block without clicking. The hover mode is displayed as ants marching on links. Focus mode. This mode is enabled when clicking on a block. The focus mode is shown as bold links. Function graph. Hover and focus. Scope flow to and from a block. Blocks after, from, must have passed through a hover or focus. Blocks before, to, must eventually pass through a hover or focus. Paths to and from a block go from entry block to return blocks. Loops containing a block, show the local loop neighborhood. For those unfamiliar with dominance in graph theory, the basic idea is that some nodes are more important than others, because they act as dispersing or condensing gateways for flow. Show scope flow from block. This will encompass all blocks in the flow after the principal block, that can only execute if the principal block executes. In other words, if control never makes it to the principal block, none of the neighborhood blocks will execute. Show scope flow to block. This will encompass all blocks in the flow before the principal block, such that all blocks in the neighborhood must have executed if the principal block executes. Function graph hover, special. Paths from focus to hover. With the focus block selected, the from block, and the mouse hovering over the to block, the function graph will show you all the possible flows from the focus to hover block. Function graph focus, special. Show all loops in function. Independent of currently focused block. Can be computationally expensive. In a function graph focus, you are presented with a normal task dialog when all loops are being computed. If you cancel, it will ask for confirmation and then display the results as far as it was able to get. For most functions, this is pretty close to the right answer, but it still might have missed one or two small loops, depending on the complexity of the function. Function graph. Right-click menu. Highlight, same as listing highlight menu. Selection, create from hovered or focused edges. Pop-up windows on and off, block, edge. Satellite view. Entry point is green and return blocks are red, just like zoomed way out. Click or drag to navigate in satellite. Zoom to vertex, window. Properties. Function graph. Tool buttons. Disk, save program. Navigation arrows. Undo and redo. Function graph. Group vertices. Can collapse nodes into one node. Give new node new name to represent group. Can expand node back into previous grouping. To group vertices, use the control button with right click. Drag to make a box around a group of vertices, then right click and choose Group Selected Vertices. Enter a new name and hit OK to collapse into one node. To expand back into original vertices, right click on the grouping, and choose Ungroup Selected Vertices. Function call trees. Tree view of current functions incoming and outgoing calls. Left window, incoming calls to current function. Right window, outgoing calls from the current function. Folders expand and collapse until there are no more function callers or calls to follow. To open the function call tree, either right-click in a function and choose References Show Call Trees, or choose the corresponding icon in the code browser icon bar. By default, the function call trees show all calls in address order to or from the current function. There is also an option to collapse any duplicates, and show each call only once. You can optionally toggle whether the listing navigates to the currently selected function. You can also optionally toggle whether the function call trees update when navigating to a new function in a listing. Course Summary. You should now be able to create, set up, and customize Ghidra projects. Perform code analysis, markup, navigation, searching, selections, and basic data creation to support the reverse engineering process. Use the hex editor, decompiler, program tree, symbol table, symbol tree, function graph, and function call trees to support the reverse engineering process. Preview of Intermediate Ghidra course. The following are a few of the topics contained in the Intermediate Ghidra course. I hope you liked this video and found it helpful. If you did, then please click on the like button and subscribe to our YouTube channel to show your support. You should also check out the King Solutions website, the links are below the video. See you soon, and thanks again for taking the time to view this video.